The topic here is deep copy constructor. Most of the times people tend to use the term copy constructor to refer to what I'm going to talk here. However, I prefer to use the term deep copy constructor if deep copying is involved or embedded in the constructor logic. In case if you are interested in the concept how deep copying actually works, was my previous video on deep copying and assignment, which can be found in the description below. This is a video focused on coding, therefore I am going to jump right into the coding. Here I have a code which shows you a definition of a class called student with attributes student number and the pointer, which is going to be used to store name of the student in dynamic memory space. It has a default constructor to set the object in default state. It has a custom constructor to set the object in some non-default state. It has a print function to display the data, and it has a destructor to release the memory, dynamic memory. And there is something in the main function. I will talk about this in a moment. First, let me talk. I think in this place, maybe here. Here, I want to actually talk about copy constructor. First, let me explain why it is actually needed. Copy constructor is needed when you want to create a new object out of by copying the contents of an existing object S1. S1 is defined in this line, which has the data 1001 and Harry as the name. And if I want to create a new object by copying from S1, then in this case we need we need copy constructor. If we have we don't have this resource variable, you don't need to define copy constructor, because it will try to copy this variable by variable. This operation will try to copy this member by member, so it will naturally copy from the shallow space to shallow space. All data will be copied. But if you have a resource variable or pointer variable, in that case you cannot copy a pointer to pointer, because you are copying the address that may result in both these objects S1, S3 and S2 whose S name attribute will be pointing to same dynamic memory space. You don't want to have two objects whose members are pointing to same memory space. So to avoid that, you need to explicitly define a copy constructor. So whenever compiler comes across this thing, this kind of statement, it will look for copy constructor. Right? If it doesn't find copy constructor, it will try to copy this member by member. So we need to, for this statement to work properly, we need to define copy constructor. The syntax of constructor is the constructor does not have return value, so you don't have return value, and the name of a constructor is name of the class itself, like in this case. So you're going to have name of the class as a name of the constructor function, and you have a body of the constructor. Inside the parenthesis you want to have proper declaration of the parameter to receive this object S1. S1 is student type object, so you want to receive a student object, but when you receive object, it is already advised you receive as a reference, give name st, and you don't want this copy constructor to make changes to this object. That means in this case whatever happens inside this operation, you don't want this S1 object to be changed. In that case you want to make sure that the function doesn't change, so you put constant keyword here. You receive as a constant reference object. Inside you actually want to copy in a way that is being done here in this logic like this. So you want to copy let's say the this student number from the received object student number, and you want to actually copy S name from ST, right? Just one thing to remember here is you cannot copy the name like this. If you copy, the name is actually name itself is a pointer, so you are copying the address, you are not copying the actual data, right? So when you are copying like that, you are copying the address in which this data is stored. You are not copying this data itself. So you need to properly define this copying operation. Uh, the way to do that is, first you need to create a memory space to store the data to be pointed by this S name. So this is the way you actually allocate memory: new keyword, character, and then the size of the name in the received object plus one extra character for null character. So you allocate memory and then you copy the name data using this function. Now this will actually solve the purpose of copying the things. If there is no problem with the student object is okay, it is holding the valid data. But in many cases the student object may not have valid data, right? So if you are trying to get invoke this function, it will try to access the data from this pointer, and in case if the student object S name is null PTR, then that will lead to runtime error. So you actually want to validate the data before you want to copy like this. So validation is important. The way of validating is if put a condition and put everything inside the block, if block, and you're also going to have else block. Now the condition is the condition that will actually return true, evaluate to true when the data is valid. That means st dot s name is positive and st dot s number is positive, st dot name is not equals to null PTR, right? So if these two things are okay, then you can copy the data. Otherwise you can set this, because constructor will obviously create an object, so you can set this data to the default state, like in this case default values, right? This is the constructor which actually solve the purpose. So it will copy, validate the data, allocate memory, like this, right? Remember, if you have any kind of memory allocation in the custom constructor or some copy constructor, you must have the destructor defined if you want to avoid the memory leak problem. So this is the copy constructor. With this we can have this thing working. Let me comment this out. So first let me run this code without constructor. I want to comment this out, this constructor logic, and I want to demonstrate what happens if I try to run this thing, and afterwards I want to actually print s3 dot print. Now let me switch to the terminal and compile and link and execute. Now it is stuck there, it's not displaying anything. That means there is a problem. It's the problem is with that particular line. Let me switch to this. So now we have the problem in this line. For example, if I don't have this line and go back to the terminal and try to do the same thing, compile and execute. I think there's a well, the problem here is I have used this S3, but this statement was supposed to create S3, so let me comment this out again also. Back to the terminal, compile and link, and then execute. Now it is executing. I don't have any problem with this. So this clearly indicates that we have a problem with this copy construction. The reason is that you actually try to copy address to another address, that results into a problem. You are trying to copy pointer, and the two objects are actually pointing, and it actually tries to do copying of one dynamic memory space to another. So that is the issue. If I uncomment this copy constructor logic here, then what happens is at this point it will try to see copy constructor and it will execute this code. So we will not see any issue here. So in that case, we can also uncomment this line, and let me switch to the terminal to demonstrate it. Compile and link and execute. Now it is executing without an issue, right? It is also displaying the data. So this was the data that was displayed from copying. This was S3 object data, this was S2 object data, this was S1 object data. S3 object was created by copying from S1, so you can see the same data for S1 and S3 object. Back to the editor. So, and it is especially important, for example, if you have this S2 object created, for example, if you create an object in the smaller scope, let's say S3, let me create a S3 object here by copying from S1. See dot print, right? It will actually display the data. Let me switch to the terminal. So this was actually data that was obtained by copying from. This was the data that was displayed by the print statement inside the curly braces. Now I want to explain this. So when you create an object, if you create S2 and if you create this object inside, and then by copy constructing, and then S3, if you don't have that constructor, then it's possible that S3 and S2 members may be pointing to the same dynamic memory space, and if S3 goes out of scope, it will delete. It will call its destructor, and then it will delete that dynamic memory space. But S1 object is still valid in this scope, and S1 may attempt to access the same data through print function, and that there comes the problem, because in this case, if it is trying to access the main this S name, because for S1 object the attribute is carrying valid address, so this is going to be true, and then it will try to access the data, and then illegal data access issue will be there. So this is the copy constructor. Just remember, let me recall the important points here. You have the function and the parameter, constant reference parameter, and then validation, and this is called something called shallow copying, and we don't need this line, and these two lines actually implement deep copying, and this is setting the object to default state. Right. So I think this is these are the essential components of this copy constructor. Thank you for watching this video. In the next video, I will focus on copy assignment operator. Thank you for watching.